Hello, good morning, everyone. And thank you for joining the IPv6 deployment section. And especially this section is focused on how we encourage all stakeholders, especially service provider, to deploy IPv6, and also sharing their deployment experience among their past experience and try to overcome any difficulty for IPv6 deployment. So let me introduce the first speaker. Suppose he will be present online. The first speaker is Amer Deshpande from Google Cloud. He's going to introduce IPv6 performance and diagnostic metrics. So let's welcome Amer. Thank you.
Hi, everyone. Thank you very much for the introduction. I'll be speaking on IPv6 performance and diagnostic metrics. So I recently graduated from NIT Surathkal and I'm currently working at Google. Okay, so let's start. Next slide, please. So RFC 8250 defines PDM, performance and diagnostic metrics. It's an IPv6 extension header. Specifically, it's a destination option type. It provides you information on sequence numbers and some of the delta times like round trip time and server processing times. This PDM data is available to you per flow. Whatever is the protocol working on the top of IPv6, PDM can work with any of those protocols. And the main ability of Pdm Veto is in diagnosing. So you can quickly find out whether the latency is in the network or on the server side. Next slide, please. Okay, so why use Pdm? So what makes it interesting? So we have a couple of co-authors who represent the enterprise perspective over here, that Pdm Veto can help them with the application level analysis. And for most of the organizations, time is a main factor where you check the quality of your service. So PDM provides you high precision deltas of the order of attoseconds. Then it can quickly tell you whether so you'll have the entire RTT time, and then you'll have the specific node processing time. So this can help you with easily figuring out whether the delay is in the network or whether it's in the server. And another thing what PDM adds is sequence numbers. So IPv6 is stateless by design. So sequence numbers can help you track every flow, the packets going, and it can help you in packet level debugging. Next slide, please. Okay, so yeah, as I mentioned, so there are multiple services which rely on time, and some of the examples are given over here. So emergency police contacts operates over IP, then law enforcement acts over IP networks. Stock exchange websites require a low latency. Then many cloud services are based on low latency services. So yeah, so PDM plays a very important role in all these scenarios where you need to debug the issue, and specifically if it's an application level issue only occurring for say a few flows but not for others, then it plays a very vital role in all those cases. Next slide, please. So okay, and now considering all the benefits of PDM which I mentioned in the previous slide, there were some limitations which were mentioned in security section. So the three limitations broadly were that the data which we mentioned before, the round trip times and the sequence numbers, they were going unencrypted on the wire. Then destination client was not authenticated, any server, any client which is reachable to the PDM server could potentially get the PDM information. And the last limitation was that, which is common to extension headers in general, that extension head they could be used as a covert channel. So there should be an integrity check so that it doesn't get altered in between. So to tackle all these issues and maintain the benefits of PDM, we decided to work on Pdm Veto. Next slide, please. So Pdm Veto mainly, so the new things which Pdm Veto provides is encryption, authentication, and integrity. And for this, we have adopted the HPKE framework. HPKE recently was made an RFC, RFC 9180. So what we did in Pdm Veto is we divided it into two phases mainly: the registration phase and the data transfer phase. So broadly, what registration phase means is all the communicating parties should share a common secret or the common context, and then the data transfer phase is the regular transfer of packets where Pdm Veto is applied. So Pdm Veto also allows for unencrypted PDM data flows. The unencrypted option is kept open in case say PDM is operating in inside company's domain, or if it's a trusted environment, then you could go with the unencrypted one. So the registration phase is independent of the data transfer phase. So if somehow the entities have the required secrets, they could directly start with data transfer phase. And currently we are focusing on the data transfer phase. So this is what our current work of PDM mentions. Registration phase is still in progress, and we keep it open to the organizations to implement their own registration phase. So, okay. Next slide, please. Okay, so this is the Pdm Veto architecture. We have adopted a primary secondary architecture. So you can see there is a primary server, and then you have primary client. There could be multiple, a primary server and secondary client. So there could be multiple secondary clients, and similarly primary server and multiple secondary servers could be there. The reason for going with such an architecture is to reduce the one-to-one key exchanges. So we believe that most of the organizations have a huge amount of traffic, and PDM registration is so PDM registration would just add to the additional traffic between one-to-one servers. So to reduce them, we decided to adopt this, and also it gives an enhanced control over which secondary clients should actually access PDM data of other secondary servers. So we have decided to go with this architecture. If you see in the initial arrows starting from 1 to 11 specifically, so the blue arrows and the red arrows, they are specifically the registration phase, and the last green phase, the 12th number stage, is the registration protocol. So sorry, it is the data transfer protocol. So this is the high level design what we opt to come up with. So first, the primary clients and the primary client and the primary server do a registration amongst themselves. They perform the HPKE key encapsulation mechanisms. They share a list of IP numbers of the secondary clients and the secondary servers. then the rest of the procedure is on the respective organizations. So within the primary client and the primary client and the primary server domains, you'll have registration amongst themselves. And finally, you have a shared context. You can potentially start with Pdm Veto encrypted data flows. Okay, next slide, please. Okay, so what's more in it for the audience? PDM addresses some of the common issues that are related to IPv6 extension headers. So in general, extension headers face issue with integrity. As I mentioned, it could be used as a covert channel. To avoid this, so some of the PDM features are quite beneficial in this scenario. Then with respect to confidentiality, if any sensitive data needs to be sent as extension headers, Pdm Veto can allow for that. And yeah, authentication, of course. So the way we are designing this Pdm Veto architecture is that it could be extended in general to other extension headers. We are designing it with the optimal required security. And I think PDM, so the HPKE suite does offer us the flexibility of protocols. So this is the cipher suites you want to use. Depending on the cipher suite, how strong or how your security should be, you could go with some of the combinations present over there. As for the applicability for hop by hop, we are still in discussions regarding it. Right now, our architecture is suited for destinations option type, but definitely hop by hop is something what we are considering, how we could encrypt hop by hop extension headers, because essentially we are trying to solve the issue or a security limitation in extension headers itself. So next slide, please. We have done some implementations and testing for the same. So we have an implementation in Linux kernel for PDM and Pdm Veto. Apart from this, our registration protocol, as I mentioned, we are still in discussions, and we are deciding to come up with a new draft regarding this. So our registration protocol is also we have an implementation, but it's still developing at this moment. But definitely the Pdm Veto the data transfer phase, what we propose is independent of registration protocol, and we leave it up to the organizations how they want to implement the registration protocol. One way what we proposed before was primary secondary architecture, but yeah, that is what we have implemented as of now. So apart from this, we also took part in general extension header testing. So PDM and in general some other extension headers. So mainly Pdm. So PDM, Pdm Veto and Pdm testing we did across internet. This is the image of testing we did. So we were working between Vultr and DigitalOcean machines. So in general, what we wanted to test was whether extension headers are passing over the internet or whether they're getting blocked by some of the intermediate routers. In all our testing between the locations, Chicago, Singapore, and Chicago, London, Singapore, London. So there was some combination we tried, and in all the cases for this experiment, we observed extension headers were passing through. We did some more testing as well after that for testing it against a few websites like facebook.com, google.com, and many other top websites which face a good amount of traffic on daily basis. Mostly our observations were that PDM and extension error packets were getting dropped mainly because most of the traffic went through the CDN providers, and we are getting to understand why and what are the reasons. But mainly what we observed was the traffic went all the way through the internet, and it happens to be a phenomenon at the end of at the destination network. So we are currently looking into all those scenarios of extension error testing. Next slide, please. Okay. So I recently started with IETF. This is actually about me. Just I'll quickly wrap this up. So in March, I got an opportunity to attend IETF 113, and I would really like to thank ISF Asia, APNIC Foundation, and ISOC for this. And yeah, so I started working on this during my pre-final year, and it was yeah, great for me to visit IETF in person and yeah, go over there as a student. So thanks a lot. Okay, next slide, please. Yes, so these are some of the references to what we are doing. There's some material on the talks, and the current Pdm Veto draft what we are working on, it's currently under IPPM working group. And yeah, okay, so I think there's a typo in the references, or okay, it's all right, the numbering is 111. So the second link is the internet draft what you're working on. I think that concludes my presentation.
Okay, thank you, Amir, giving the wonderful presentation regarding to performance. We leave like all the Q&A to the end of the session. Can I? Oh, okay. Sorry to mention that. And by the way, before move on to the next speaker, I'd like to express my gratitude and appreciation to IPv4 More because he is the kindly sponsor for the section. Thank you for IPv4 More. So now I move to the next speaker. Musamo Masalen, he is the APNIC community trainer. He's going to give a presentation on IPv6 deployment experience in Telecom Malaysia. Okay, right, thank you.
Well, thank you, Dr. Kenny. Good morning. My name is Muzamer, and I am from Telecom Malaysia. So for today's sessions, I'm going to share on the IPv6 deployment experience in TM. And to start the today's session, so I wanted to record what Dr. Philip mentioned in his previous presentation in the APNIC. So it goes something like this. You can't just wake up in the morning, get a cup of coffee, and decide to configure IPv6. It doesn't work like that for us. So in Telecom Malaysia, the journey we took it as a journey, and it all begins in 2004. But all of the heavy lifting actually happened in 2009 up to 2012. So I'm going to cover on the next slide, which is we focus on the deployment. We started in the infrastructure first because this is the one which we have the full control. And when we got the first IPv6 delegation in 2004, so what we do was we planned on how we wanted to delegate this IPv6 and a few things to consider. Back then we were running OSPF, and we are taking care of two different infra, which is separated via the internet, and one of it is the VPN. And putting into consideration that we have to revamp to have the capabilities to have the IPv6, so we took the opportunity to fully modernize our network. And in 2008, so we begin the integration of the ISRS, replacing the OSPF. And coming to that, we also have the capability to enable the MPLS, which enable us to turn on 6PE, and we have the dual stack. So now we got the infra covered. So what's next is for us to bring in the content. So we peer to our IP transit, to our peering to our upstream, and we peer via the door stack to get the content in here. But it doesn't stop there. So we wanted it to be better. So we have all the CDN partner, and we are connected with the IPv6. So now we have the infra, and we have the CDN content. And next is for us to deliver the service to our customer. And this is on the access portion. And honestly to say that this is a part of the most of the challenge happen in here, because when we are talking about delivering the service to the customer, we have to think about what about the existing customer? Does the CPE able to support IPv6? And for the new one, that's easy to cater because we will test it out, but we still need to cover end to end. And then we started the testing for the door stack back in 2010, and we performed the user acceptance test in 2011. So what we do is that we pull in every CPE that we have in the network, bring it to the lab, connect it and test it with the infra that we have. We have in the lab and in the production. This is to ensure that when we go for the rollout, our user experience will be protected and we are giving the best services to our customer. And in 2012, we started to roll out the dual stack CPE, the one that we had tested, and the CPE that I mentioned earlier for the existing one in the network. So we have two ways looking at it, which is the CPE, which if by upgrading the firmware, so we are able to deliver the dual stack, and the CPE, which we have to replace it. So to make it simpler, so we use the R69 for us to push the firmware to the CPE, which we able to support the IPv6 just by upgrading it. So less manpower that we have to use to go to the home user and to replace the CPE. But for the one that we are not able to do anything with it, so we just go with it, send our team and replace the CPE, because we know that we have to do this. This is what we wanted to deliver. And roughly said within that year also in telecom, so we got all of it covered. We got all the infra covered. We are able to deliver the dual stack IPv6 to the customer. And in Malaysia in 2015, so MCMC is the regulators for the communication in Malaysia. And the good part is that they push out an act which say that all of the ISP need to deliver dual stack IP to the customer. This is really a good thing for Malaysia. And good for us is that we got it covered a few years back. And in 2016, so telecom required the mobile provider, thus we are giving the same thing, which is the dual stack to the customer. And with all the heavy lifting, with all the hard work being delivered, so we are glad that today we are number 27 among 300 plus, and this is being measured globally from the Internet Society Pulse. And it's good that we are able to be together with the other leading global telco in the IPv6 adoption. And this is the updated info from HE, which is the number of IPv6 pairing and IPv4. And if you notice that the number is quite the same, meaning to say that in any of our future connectivity, currently it's everything before IPv6. And on the other side is the first/32 that we got from the APNIC back in 2004, if I'm not mistaken. So it's raw assigned. And just to update also that in telecom, we just recently enabled RPKI validator a month ago. We are not yet dropping the invalids, and we are still connecting our global POP to the validator. But this will be on another update. Okay, this is on our deployment guide. So first thing first, I think when we decided to deploy, the first thing that we do, and I would say that this is the crucial thing, is to get the awareness right, because it's not just the engineer that need to know how to configure. We need to deliver the same thing, the same understanding to the on-site team, to the sales team, to the NOC, and even to our customer. And with the right awareness, we are able to get the full support from our top management. This is important because for us, my portion is only on the core network, on the edge, on the global, but delivering the IPv6 is end-to-end. So with their full support and with the right awareness, they can spearhead the same initiative to the rest of the other division in TM. So we are looking at the core. We have another division looking at the CPE. We have another division looking at the NMS, because we are talking about end-to-end deliveries. And moving onward for that, aside from that, and another thing that we agree upon that we need to ensure that we saw the need to be future-proof, and IPv6 is one of it. Upon that also is that any expansion in TM, so we put a clause that everything going in, it need to support IPv6, and it's not just the core, it's the CPE, it's the firewall, everything, for us to future-proof our network. And last but not least, any security measure that we put in the IPv6, the one that we are running in the network. So we replicate the same thing for the IPv6. We are not neglecting the security, because opening up a new possibility, meaning to say there is pros and cons to it. This is the challenges that we saw during our deployment. So the first one is that in TM, so we are not locked down by a single vendor. We are running multiple vendors, and with the multiple vendors, everyone have a way of doing things. And what we took from it is that we take the advice, but everything will be, the decision will be on TM. And how we manage this is that we follow the RFC. This is the best practice. And it's not just that by black and white. So we focus on testing, when we are testing, everything must go in. It doesn't really matter how big or how small the device is. And number two, we don't have the luxury of turning up the IPv6 capabilities bottom up. So we have to take care of the new infra that we wanted to build, the existing infra, the legacy. So what we do is that we prioritize things. So router which are able to support IPv6 just by upgrading the firmware, we do it. But for routers which are not able to support the IPv6, we have to put in cost to replace the routing engine. So we put into consideration migrating all the services into the new box. So we prioritize things so that everything can go through inline together one by one. Number three, the one that I mentioned about the CPE, massive number of devices. We have millions of customers, and every customer is still a customer for us, and everyone is important. So working it out is we use automation to make it easier for us to manage our customer experience, to manage our network, and manage our devices. Number four is the regulatory. This is the one that I mentioned about the support from our regulatory bodies, MCMC. And if you were to put into consideration back then, CPE, which are able to cater for IPv4 versus CPE, which are dual stack, their price is not the same back then. So cost is something for us to consider also. And if the price got a little bit cheaper, or it doesn't really matter, V4 or V6, it cover both, it will help us a lot. And the content, back then we didn't have much, but good for us. Something today, everyone see the needs and the requirement to have the IPv6. We have the full support from our upstream, from our CDN partner. So it's good for us, human nature. So this is our problem. I bet that you guys has friend that in a way to say that if you say it to him, do not do this, do not click this, that's the first thing that he'll jump and do it. So this is a challenge for us. Because when we deliver the dual stack to the customer, what they do is that they disable the IPv6 just because they read somewhere saying that by turning off IPv6, their connection would be faster, but that's subjective. So what we do is that we do a little tweaking on the GUI to disable that function. So keep it simple and it solves the problem for us. And the last one is on the security measure. So when we are talking about the security, it's not a day one deliveries, it's ongoing effort. And I think the best place for us to learn is here. So we have all the experts, we have everybody, we can learn from the other ISP experience on the IPv6 protection. We don't have to experience the same attack for us to deliver the same protection mechanism. So we learn, we talk, and this is the right place for us to be. And okay, what's next in TM? So yes, we are well aware that with the depletion of the IPv4, so TM aspiration is to further explore and deploy IPv6 with below driver, which is explore the new use case for the IPv6, for example, 5G, IoT, and cloud, and further increase the IPv6 content footprint in TM, and involve and keep on spreading the awareness to all. Okay, last but not least, before I end my session, so what I can advise for whoever considering in deploying IPv6. So do what you can with what you have, where you are. Start now. And if you need some information, just ask something. Everyone is here to support you guys. Well, this shall end my session. Thank you.
Thank you, Musama, for wonderful presentation, especially introduced the Telecom Malaysia experience. As I said, very valuable to all participants. So I'd like to move on to the next speaker, Xiao Wenma from Google. He's going to introduce IPv6 in Google Cloud. Let's welcome Xiao Wenma.
Thank you. Where can I turn? Oh, okay. Good morning. Yeah. Oh, here. Oh, got it. Yeah. Cool. Good morning, everybody. Really nice to face-to-face meet all of you here. I'm a group of product manager from Google. So today I will talk about the cloud IPv6. So we understand that for the past few years, all the telcos, consumers already get ready to migrate to IPv6. Now, cloud actually can take a great part of responsibility and help our customer, telcos, consumers to move on IPv6 here. So then we talk about how difficult a cloud provider migrate from IPv4 to IPv6. Then what's a key differentiator between the IPv6 VPC versus the legacy IPv4 VPC here? Then we talk about all the cloud products you need to upgrade to support IPv6 here. Then later we can talk about the many innovation here. So I'm a product manager focused on APAC and a lot of networking products in Google here. So from this picture, you can see IPv6, especially in Asia-Pac here, is really happening. The biggest percentage of user adopt IPv6, which is India, Belgium, Germany, Malaysia, and China, Japan. So all the country are going for IPv6. Why? IPv6 is so urgent right now. Even all the cloud provider need to consider and adopt IPv6 as soon as possible. So right now, the IoT and 5G is really the driven for IPv6 adoption. So if you look at all those smart city connectivity, healthcare, AR, VR, everything together, the IPv4, which can only offer 4.2 billion, which is 9-10 devices to connect together. But there's a Gartner forecast by 2025 here. So over the 4.5 billion IoT connectivities, majority will be 5G connectivity in the market here. So compared with all the IPv4 address here, it's not enough. But if you move to IPv6 here, you definitely have a 3.4, like a 38.0 followed by 3.4. So which is a much bigger than all the IoT equipment for the 2025 or for the next 10, 20 years to come. So that's why the 5G and IoT really push the boundary here. So we saw a lot of our cloud customer, asking for IPv6 support here. But IPv6 in cloud networking is never an easy way to achieve. So Google starts the searching function, offer the searching to public around the 2000, 2006 somehow. So at that time, we defined the global cache, then followed by a massive scale data center, Watchtower, Freedom, and Maglev, which is a software-defined load balancer. follow the software-defined WAN networking, software-defined data center Jupyter, Andromeda software-defined virtualization, then Espresso software-defined edge. Then recently years, even 2020, 2022, 21, 22, we launched the Swift, and which is for One Army Cloud RDMA here. Then last year, we launched the new SDN controller, which is Orin. So for our Jupyter and Espresso, some controllers for software-defined control plan here. Then this year, SIGCOMM and others, we launched the new unified fabric for ultra low latency HPC AI fabric here, so-called Aquila. So if you saw everything here, so Google basically redefined the networking by software defined. So a lot of innovation happening. So everything I talked today here, all those innovation past 15, 20 years, we need IPv6 support. We need to kind of support IPv6 for every component, from the CDN cache, from load balancer, from a data center, from virtualization, from the new AI machine learning fabric here. So basically everything in our data center, we need to support IPv6 immediately. So we talk about the east-west traffic and the north-south traffic here from the cloud data center here. You can see we connect a lot of our customer by SD-WAN interconnect. So we need a IPsec, IPv6. Then for the edge POP, load balancer, CDN, and DNS, we utilize a lot of MPLS. MPLS over GRE, IPv6 will carry on top of MPLS here. Then there's like a backbone B2, B4 data center cluster. So inside Google, all our new data center fabric is already starting from IPv6. So we not assign any IPv4, even the private IP address is running out inside Google. So any new infrastructure, we automatically assign the IPv6 address already. Then on top of for the storage and the container applications, of course, everything will be IPv6 eventually. So what's the biggest benefit for IPv6? So previously, we always worry about the outside network and the internal networks. So we always use Net 4.4. So Net 6.4 could be used for certain scenario. For example, our customer still have an IPv4 data center. They need to access IPv6 cloud here. But if you look at the Net 6.6, which is strictly against by a lot of IETF member and a lot of guidance to not deploy Net 6.6 here. So why so? Because you have so many IPv6 address, why you translate again? So how do you design the VPC without Net 6.6? That's a key question here. So if you look at the cloud networking here, so from the user administrator and inside the public cloud and the private cloud here, there's a lot of product you need to upgrade to support IPv6, like a CDN, like a load balancer, DNS, a VPN, interconnect, and also Cloud Armor for anti-DDoS, firewalls, storage, and everything here. So you can see, if I already have Cloud Armor for anti-DDoS, I already have firewall for security, why I should take Net 6.6? Should I really try the network address translation for IPv6 or not? So let's go back to the fundamental. So a lot of our customers actually deploy just like this one. Yes, of course, we have enough IPv6 address, we can assign the public IP addresses for every virtual machine, every containers inside cloud. But we don't want to do. Why? Majority of the application from front end and back end, the back end, there's a lot of database storage and everything. Those infrastructure, those information, they don't want to share outside of the cloud, or share to vulnerable for scam, vulnerable for attack, and so on. So majority of our customer only have like a less than 1% of a virtual machine or less than 1% of a container or who need a public access. Majority of the virtual machine, they still need a private IP, private address here. So even for cloud, even we have enough, like a 34.0, every component can assign IPv6 address, but we still need to have the unique local address, which is equivalent to the RFC or 1918 here for the private address here, because we don't want to expose those information outside. So if you have the ULA, then you also have the connectivity of talking to the public. How do you do? How do you support the ULA? In the meantime, access the public internet here. So if you look at this IPv6 address, so Google got assigned by 2600 here, 1900/28. This is a Google block here. Then we also have a ULA IP block from FD20 here. So we kind of design in a certain way, /48 for VPC, /64 for subnet. Then the cloud with IPv6, which is quite different. All the virtual machine previously for IPv4, they actually getting a unique /32 address, right? So if you go with IPv6, normally you get a /128 address for each individual virtual machine, right? But we don't want to. We want to assign a bigger block for every virtual machine. Why so? Because the whole container networks will get IP address from the virtual machine. So instead of one single IPv6 address, we assign a block for those virtual machine. So anything on top of this virtual machine can get automatically assigned pod and container IP addresses. Every individual pod actually can get the /128 address here. So yes, if you look at, I need the ULA, I need the public talking. So some cloud provider just thinking, okay, that's easy. Let's go continuously use NAT6s. So they offer the option to leverage the NAT6s very easy. So the public facing, they use the GUA, global unicast address. The private facing, they use the ULA address. But that against the fundamental IPv6 principle from the very beginning of their design here. So we actually offer a different way. So if you have like a private only VPC, you can assign the ULA address for private. Then this private IP addresses can easily to talk into the private cloud. Then the private data center, they have the similar FD20 start prefixes here. Then if you need to access public information, global internet here, you can actually assign those virtual machine to with a 2 NIC card. The virtual machine normally have one single NIC card, but this time we design by, if you need public access, we give you another public GUA address. So those virtual machine, which belong to 2 VPC, one VPC internally, another VPC for public here. Of course, we do have others design to support, which is starting from 2017. Google, even today, we're still migrating our IPv6 to support our customer. The backend still a lot of IPv4. But from 2017-18, at that time, Google is the first cloud provider support IPv6 with IPv4 backend. So how so? We actually can support a lot of user, like a mobile user from India, from Singapore here. They assigned IPv6 address already. But this IPv6 address will not set up a directly connection to the backend. So they actually can terminate the session in the load balancer. We have a global load balancer across 173 locations worldwide here. We peering with all the public telcos, TM, Syntel. So those POP, we very nearby the telco edge here. We actually terminate the IPv6 session. Then we tracking this IPv6 session, we start a new IPv4 session from backend. So you don't need to upgrade any of your infrastructure, your services, your existing server, but you still can support millions of IPv6 users here. So these services have been in services for past 5-6 years already. We support a lot of IPv6 migration. So now we are working on from POP, from the edge location backend to the cloud. Everything will be IPv6 here. And also, of course, a lot of our customers really have their own IPv6 only data center private cloud already. How do you connect this one to Google Cloud here? So we actually use the customer peering router and the Google peering fabric. The peering fabric not terminate any IPv6 session. So the IPv6 session is terminated into the cloud router. The cloud router, which is one customer can have a multiple cloud router for backup purpose here. Then we can support SSU in-service software upgrade for the cloud router, because cloud router is only the data control parts. Then we support a BGP, grid for radar, BGP, BFD, everything here to help you to during the migration, during the software upgrade, without any packet loss here. So then we need a interconnect gateway to connect to the VPC, because you need to do a little bit of translation and information identification and so on. So the next big topic is why our customer need IPv6 in cloud. Some of our top customers, they are running out IPv4 address. I'm not talking about the IPv4 address in public domain. I'm talking about the IPv4 address in the container networks, because they deploy so many containers. The RFC 1918, like 192, like a lot of or the 10,000 something is all running out. So some of a very big cluster, the IPv4 private address running out. So that's why they rush to the IPv6 for container network here. So recently we support the IPv6 based container networks. So we use eBPF, we use all those Selenium based so-called data plan version 2, Envoy, everything we support IPv6 already. So now you can actually really to scalable IP address here. So previously you need a private IPv4 address for every pod container services. Now you can change to IPv6 easily here. So this is the dual stack IPv4 v6 for the GKE networking, and we can support all the container networks from deployed in the on-prem data center and also the GKE private cluster in Google Cloud here. So going forward, like I mentioned from very beginning, so IPv6 edge like edge networking, all those 5G, IoT, smart cities, smart retail, telcos, smart city, healthcare, really driven the IPv6 adoption. So it's kind of from the user to the telcos to the cloud edge. now go inside the cloud network. So the cloud network need to ready to support all the IPv6 adoption here. So we are the first, one of the first cloud providers support IPv6 end-to-end here. We are really welcome every telcos, partners, and customers to discuss with us, can design the new IPv6 networking, because like I mentioned, the whole cloud networking IPv4 VPC is designed by Net44. So between the different VPC, then if you from VPC go outside of network, you need a Net44. But how do you get rid of the Net66? But in the meantime, you can still continuously to innovation in IPv6 in cloud. So that's something we really want to get your feedback and so on. So that's conclude my session. Thank you.
Okay, thank you, Xiaowen, by giving the full introduction about the cloud service provider requirement on the IPv4 v6 combination. And also, I just move to the next, the last speaker, Osper Anderson, and he's from Mobicom. He's going to introduce enable IPv4, IPv6 dual stack infrastructure. Let's welcome.
Thank you. So I will quickly introduce how we enable dual stack network in transit provider. So I hope today most network enabled the dual stack. So if you not enabled the dual stack, my presentation will little bit help for you. So my name is Oswald, and I'm from Mongolia, and I'm working for Mobicom Corporation in Mongolia. So here's the agenda, and first is IPv6 addressing and subnetting and implementation and issues. So I think most important part of implementing IPv6 is address planning in first start. So our addressing was not good for engineers. For example, we use the IPv4 address encoded to IPv6 option, and that makes some complexity for operation. There are digit and alphabet combination. Actually, you can see here, and this one is not human readable, and engineers is avoiding to working on IPv6. So also typing keyboard, and it creates the little complexity. So then we replanning whole IPv6 addressing. Then we use the more simple way. So here's the readdressing. For example, router 1 loopback address will be here, and link local address also more simple format, and it will more simple for operation and understandable for engineers. Then subnetting. So we got /24 address from APNIC, and we divided them to /36, and then we are divided to /40, and end customer will be addressed in /38. So here's the subnetting for metro area, and we divided the metro area in 4 areas, north, east, west, and south. And we assigned the 1/36, and each area has the /40, and each site has the /44, and that means each site has the 60 user capability. So we are transit providers, and most of our customers is ISP, and so some Mongolian ISPs don't have our own resource. So this /38 subnets for those ISPs. And then subnetting for rural area, we also assigned 36, and each province has a /44, and each province has coded to telecom code. For example, the middle one is telco code from each province. And each province has also 16 customer capability. And then here's the implementation. So we implemented the IP core and just enabled the OSPF version 3 and MPBGP. So routing policy is same as the IPv4, and all eBGP connection was the dual stack and transit, IXP, and PNI connection, and also CDN and MPLS network. So here's the configuration sample of how we configure them. And also our DNS resolver can resolve IPv6 domains. And also we implemented the MPLS network and 6VP. 6VP is actually existing MPLS IPv4 network can carry IPv6 traffic, and just it was the capability needed on each border router, and just enable the MPBGP on edge router. So customer edge router also enabled the dual stack capability. So here's the configuration sample for customer edge router. And this one is provider edge router and MPLS edge router. And also, here's the output of IPv6 routing table, and you can see we have default route from MPLS network. And this one is this one is how we see in edge routing MPLS P, and actually 6VP provided the IPv4 next hop address map to IPv6 address, and for FFF brings here. Then we have some issues we have faced, and that was the some P and C routers already configured the this command, and this command means this virtual router cannot support for IPv6, so we need to delete and reconfigure that VRF in order to run to IPv6. So then reconfigure this command Then we enabled the IPv6 address family on this virtual router. So we did in maintenance window because customer traffic was a couple of minutes interruption. So also we have used some old catalyst switches and their default behavior was not supported the IPv6, and we changed their default behavior and we reloaded them. Then that switch support to dual stack. And last, yeah, today we don't have any IPv6 traffic from customer. I hope next year or next 3 years we got some traffic from customer. And thank you.
Thank you. Okay, thank you, Oscar. So let's conclude all the panel discussion. And so we now move to the Q&A section. Is any other question to the old speaker? No question? Okay. Right. So if there's no question, and I'd like to invite all speakers who is here go to the stage because we're going to have a group photo and we have small gift to all speakers. Can I invite all speakers go to the stage? Okay, thank you.